Hello sir, this is Adarsh Sharma, roll number 20 ME3AI10. I'm currently doing BTech project under you in slum prediction using computer vision and deep learning techniques. Starting with the data preparation of the project, we extracted the required images by utilizing the features provided by Google Earth Pro, and we further fine-tuned the images by modifying the resolution and other aspects. As far as fine tuning of images is concerned, it corresponds to resolution of 1920 cross 1080, and I alt value is positioned above the earth surface in the range of 980 feet to almost 1400 feet. Then for the annotating the images, we use the make sense AI to annotate the image and exported the annotated images in the CocoJSON format. Uh, Now coming to the UNet model, UNet is a convolutional neural network architecture used for both binary and semantic segmentations in image processing. It consists of contracting path called encoder to capture context and an expanding path for precise location with skip connections to combine high resolution features, facilitating accurate segmentation tasks. We've improved the performance of the UNet model by using learning rate scheduler and early stopping in the model. Moreover, after the training of the model for various combination of different loss function and optimizers, we found that the best possible pair of loss function and optimizer are focal loss and Adam optimizer. After the train test splitting, our training dataset size is almost 2738 and the test size is 710. Uh, Adding pre-trained models like DenseNet and EfficientNet which are trained on million size datasets, actually ImageNet dataset in the encoder part, and freezing the encoder weights during training, we can take the benefit of the learning made by these model on mostly on millions. Basically, we can take the benefit of the learning made by these models on the large data sets. Coming to the DenseNet, DenseNet is a deep neural network architecture that maximizes feature reuse by connecting each layer to every subsequent layer. This dense connectivity improves the information flow, encourages feature reuse, which is very important, and enhances the model's performance. Our model pre-trained on DenseNet 121 gave the accuracy of almost 90% and F1 score of about 74%. Coming to the EfficientNet, it is a family of neural network architectures that achieves super performance with fewer parameters. It introduces compound scaling to balance depth, width, and resolution, optimizing computational efficiency and accuracy across a range of tasks. EfficientNet B0 is faster, but it is comparatively less accurate as compared to EfficientNet B7, which is computationally expensive, which takes more time, but it is far more accurate. Actually, EfficientNet B0 has a simpler design with lesser mobile net layers, and EfficientNet B7 is a more complex design with more layers, and hence it takes more time to train itself and give the final out. Our model pre-trained on EfficientNet B0 didn't perform well, and we can clearly see it gave masks which are not much similar to the original masks, which clearly shows that it is not a good model as far as our current data set is concerned. However, when we used EfficientNet B7, it performed well and gave accuracy of more than 91%. Uh, we can clearly see the masks are also very similar. Now, after training the pre-net UNet model for each of the variants of EfficientNet, we got the graph plotted which compares the performance of which basically compares the performance of various EfficientNet models uh, which are placed at the encoder site in the UNet model for image segmentation. We found that the best result are coming when we are having EfficientNet B7 as our encoder, when we have EfficientNet B7 as the encoder of the UNet model. But we know that EfficientNet B7 is far more complex as compared to other models like EfficientNet B3. So it takes a lot of time. It has more computations. So it's better to take EfficientNet B3 as compared to EfficientNet B7 because we can clearly see that almost the performance matrices are similar as far as EfficientNet B7 and EfficientNet B3 is concerned, but EfficientNet B3 is far more faster as compared to EfficientNet B7, so we should take EfficientNet B3. Finally, after comparing all the after training the various codes for various models, we found that the UNet model retained on EfficientNet B7 was the best model, but it takes a lot of computation, so it's better to use EfficientNet B3 in basically to use UNet model with EfficientNet B3 as encoder, which is going to take lesser computation comparatively as compared to EfficientNet B7 encoder UNet model, and it will be having an accuracy which is almost going to be similar to the model which has encoder as EfficientNet B7. As far as the future works is concerned, we can work on various other models, and not only on various other models related to image segmentation, we can also work on various other fields in the computer visions like image classification, pose recognition, and all various other techniques, various other tasks. We can work on them, and also we can work on new data sets and train the current model on the new data sets to see what is the overall performance of the model on these newer data sets.